Hello, my name is Craig Savage, but you can call me Doc, and welcome to another episode of Real World Analytics for What Schools Don't Teach You, in the coffee series, where I get a cup of coffee and discuss something and give you my point of view as a data analytics professional. And once again, I have something from LinkedIn, which I'll put here. It's a post by Neil Chapman, where he has an infographic about the different types of data scientists and which probability distribution they fall into. He even says, "Excuse me, I hear you say?" Yes, take a look, everything will be clear. So if you'd like to hear my thoughts about this infographic and you want to go grab yourself a cup of coffee or some other beverage, if you hit the pause button, I'll wait for as long as you'd like. So let's talk about this infographic. So he says, data scientist, what type are you? And he produced his own. Before going much further, my first point of feedback to Neil is good on you. I'm glad that you were able to share this. Sharing something on LinkedIn isn't always easy, especially if it's something you're doing for the first time or you're not very experienced with. So my first point of feedback to Neil is good job. You might not understand how difficult it is to share things like this on LinkedIn, but trust me. And so he's going through the data science pipeline, the skills required, and different types. So let's have a look at the graphic itself. For me, looking at this as a data scientist, the first part is the data scientist, which one are you? So I'm assuming that his target audience is data scientists looking to classify themselves, or perhaps budding data scientists looking to get into data science and trying to decide how they should specialize. So this is different from, say, a recruiter or a hiring manager who sees data science as this huge, ill-defined term, and they're not entirely sure what they're looking for, but that doesn't seem to be what he's talking about. That's different from another infographic I've seen, which I'll put there, which talks about different skills data scientists should have and why you need them. I've seen quite a bit of discussion about that one, where that no one has all of those skills, followed by some comments saying, actually, I have all of those skills. It's a different matter, getting off topic. So back to his infographic here. When I look at this again, it's a data scientist, so it's talking to me, and I see some words, oh look, graphs, let's go down to the graphs. And as he said, that he's named them all based on different types of probability distributions. So we have normal, Poisson, beta, log normal, and then the uniform, which he's called unicorn, which I really appreciate that he's saying that this is unheard of. My first part of feedback to Neil would be whether or not you want to have a uniform, so the jack of all trades, who's an 8 across everything or a 7 or 6 across everything, which is good at everything, but not the unicorn. The second one is a bimodal, that if you're good at the access and interpreting, but math is hard for a lot of people, you might want to put those in. It might disrupt the flow of your infographic, but there we have it. There's always the problem that when you classify something into discrete groups, of course you're going to have people that fall out. There's questions about what does it mean to be a 10. Never mind. It's nice for this conceptual graph about what different skills are. So now that I've looked at the graphs, let's go back and the words. And I like that he's got this parity that the different colors and the different ordering corresponds to these. Whenever I see colors like this that have about the same saturation and the same texture, I always wonder whether or not they're colorblind safe. So if you're looking at colors, double check that they're colorblind safe. These look okay. The red and the orange might not be, but never mind. So first he's got access to the data. This script that he has in the high level, I find fine, but then the skills you need underneath are difficult for me to read at the resolution on my screen. Yes, I can zoom in. Yes, I've read them. And there we have it. So access, cleanse, explore, modeling, and interpretation. Something that I think is really good that he's done here is he's got the cleanse and exploration of data as different parts, as opposed to the other infographic, which lumps them all into programming and is done. The modeling and interpretation. Something else I think he could use probably as a follow-up is, okay, if you've got a normal data scientist, what should they be doing? What types of roles are they looking for? There's also the distinction about what's a data scientist, which does this canonical problem of here's some data, show me insights, versus things that are perhaps upstream. So database construction, not really administration perhaps, but defining what the data strategy of your organization is going to be. Are those data scientists? Some people say no, those are data engineers. And then the downstream processes. So if you're going to implement whatever comes out of this, if you're building a new model and you want to put that model into production, some people say no, those are development engineers or software engineers. In my opinion, you're going to need more crossover between that. So once I've built a model and I hand it over to the implementation team, if someone on the implementation team has been a data scientist before, has experience, and I say things like, I've done an A/B test, or I say things like, I built a neural network, or this is my probability of correct classification, or here's the mean squared error, and I want to use those as test cases to verify the implementation, that they know what those things are about. So I see that as coming before and after what he has on the pipeline. So maybe instead of this little part with the graphs that mean nothing, under which one are you, you can fit in that this is just that analysis phase or the modeling phase, and you're not talking about the storage of the data, the implementation of the results, or the monitoring of your model afterwards. But otherwise, I think it's a neat graphic, and I think it does a very good job of separating out cleansing and exploring of data. The final thing that I find interesting from this post, if I go down to the comments, and as of now there are only 6 comments, but 32 likes, again, because it's easy enough to click the like button, it's harder to put something out about yourself. If I look through them, they're almost all betas. We've got, the first one's a beta, the second one says, are we normal or beta? The third one's definitely a beta. The next one's definitely a beta. The next one's a beta. So it's quite interesting that if you're looking to move into data science, it seems that the field of betas, which are good at the modeling and the interpreting of the data, are common. And it may behoove you to go more into the data cleaning, data management, data access side of things, because there's less competition there. And also, in my experience, you spend most of your time in that access, clean, and explore. So being more of a log normal, if you just go about your daily life, in terms of experience, people will fall into log normal because that's where you spend most of your time, and less in the modeling, even though many people may prefer to be a beta because that's where their interests lie. In the real world, most people are going to end up being log normal because that's where you spend your time. So those are my thoughts on this infographic and the different kind of ways to look at it as a data science professional. Again, congratulations to Neil for putting this out there. It's the hardest thing about doing these things. And I'd like to hear your thoughts about where are you? What type of data scientist do you consider yourself? What types of data scientists do you like working with? And do you think you fall outside of these probability distributions? Do you consider yourself more of a bimodal, where you're good at the access and good at the interpretation, but maybe not so good at the programming in between? Do you think that this workflow is sufficient? Do you think that people before that maintaining the data, the people after that implementing or monitoring their models, do you consider them to be data scientists, or do you have different terms for them? And how does it all fit together? Thank you very much for watching. I need more coffee. And I hope to see you next time. If there's anything you'd like me to comment on LinkedIn, please feel free just to tag me and ask my thoughts, because I have lots of thoughts and lots of coffee, so I can make a lot of these. Thank you.